May I request Professor Reddy to put the video on?
Yeah. 1 second. All right.
Yeah, very good evening, sir. In fact, we are extremely sorry for troubling you because it is very midnight to you. Yeah. So I now introduce about Professor Krishna Reddy. So he is a faculty member at University of Illinois at Chicago in the Department of Civil Materials and Environmental Engineering. So I think I don't need to give a lot of introduction about it because more than me, everybody knows about him. So he is also the director of Sustainable Engineering Research Laboratory and director of the Geotechnical and Geo-Environmental Engineering Laboratory. So at University of Illinois at Chicago. In fact, I'm very fortunate to see these two laboratories in the year 2016 when I went for a conference at Chicago, which was conducted by himself. Dr. Reddy received his PhD in Civil Engineering from Illinois Institute of Technology, Chicago, USA, and BE in Civil Engineering from Usman University, and ME in Geotechnical Engineering from IIT Roorkee. So prior to joining the University of Illinois at Chicago, Dr. Reddy worked as a civil engineer and a project manager for 3 years in industry and worked on several major civil and environmental engineering projects. So he is also one of the registered professional civil engineers in the USA and an envision sustainability professional. So his research and teaching interests include geotechnical investigation and infrastructure, environmental pollution control and remediation technologies, waste management and beneficial reuse, and sustainable or resilient engineering. So everybody knows one of his major contribution that is in the form of a textbook that is called as Geo Environmental Engineering. So this right now we are treating this as a Bible in Geo Environmental Engineering. So the title of the book is Geo Environmental Engineering, Site Remediation, Waste Containment, and Emerging Waste Management Technologies. So besides this book, Professor Reddy also has released, I think in the last year, another book on sustainable engineering, drivers, matrices, tools, and applications. So Professor Reddy is the author of 260 journal papers of reputed international journals and edited 21 books or conference proceedings and 22 book chapters and 226 full conference papers. So he has given over 200 invited presentations in the USA and in 20 other countries across the world, in fact. So he was the immense travel. In fact, he's a very big traveler. Dr. Reddy has received several awards for excellence in research and teaching, including ASCA Wesley W. Horner Award, ASTM Ozentolger Award, UIC Distinguished Researcher Award, University of Illinois Scholar Award, and the University of Illinois Award for excellence in teaching. So he is also the fellow of ASCE, Diplomat of Geotechnical Engineering, and Board Certified Environmental Engineer. So this is his, although it is very detailed, but this is very short brief about him. I now leave the floor to Professor Reddy to deliver his expert lecture. So, sir.
Yeah, so you want to stop sharing? Okay.
Yes, sir. Thanks. Sir, we are recording your lecture. Is it okay?
Yeah, that's fine.
Sir, thank you.
Okay. All right. So thanks everyone for joining this short course. So just for your information, the time here is 11 minutes past midnight. So just bear with me in case if I am a little bit sleepy. Again, so my presentation today is landfill laws and the regulations. And so, for last 24 hours, we have been very busy celebrating our July 4th holiday, which is the US Independence Day. So I just came back from fireworks. This fireworks is in my neighborhood right next to my house. There is a park, the fireworks were there. And then just July 4th, Independence Day is celebrated with parades, fireworks, friends. It's a lot of festivities. So I've been busy from morning until now. So again, busy day, but the day is not over yet until I finish my presentation. So, but anyway, so I want to thank Dr. Bhubaneshwar Rao for inviting me to be part of this short course. And I want to thank you all for taking this short course. I think it's going to be very, informative and useful if you're working on waste issues or landfill issues. So just don't get panicked. So I'm going to post my presentation in the chat box right at the end of my presentation. So you will have it. And I do want you to have it so that you can refer this one back and learn more if I've gone really a little bit quick on any slide. And you can always reach me in case if you have additional questions. So first of all, I want to mention that there is a textbook or reference book that I wrote, Geo Environmental Engineering in 2004. So it has 4 parts, as I shown here: basic principles, contaminant site remediation, landfills and impoundments, emerging waste management technologies. And this short course is to deal with the landfills and impoundments, which is in part 3 of this book. In part 3 of this book, these are the chapters. Chapter 15, sources and characteristics of the waste; landfills regulations, siting and configurations; waste containment liner systems; leachate collection and removal systems and liner design; final cover systems; gas generation and management; groundwater monitoring; surface impoundments; beneficial use of waste materials and recycling; end use of closed landfills; bioreactor landfills. So the way these chapters are organized is, these chapters go in a logical sequence. First of all, you need to know what is the waste, then you need to know the regulations, siting, and you need to know about, liner systems, leachate collection systems, final cover systems. So it provides a logical sequence of the topics. So if you're not familiar with landfills, or this is the good way to get everything organized. Because even when I was a student, my professor, the first day he was talking about the liners, and I didn't have any idea before what it takes to study landfill liners. So you need to have a lot of background about types of waste, regulations, the requirements and so forth. So in case if you are trying to teach this as a course, I highly recommend you to follow this logical sequence. And I teach a course called Design of Landfills and Impoundments at my university. I actually talk about all these topics. So this is my course syllabus in my course. So today, however, I'm going to focus on this environmental laws and regulations. So this is one of the topics that is in the chapters. And environmental laws and regulations are passed because, passed by governments due to public concern to protect the human health and the environment, because, environmental contamination could cause a lot of problems to human health and the environment. So environmental laws and regulations are passed to avoid those problems. At the same time, there needs to be a balance, because if you have excessive regulations, then it would be undue burden in terms of the financial terms to industry and taxpayers. So you need to balance that environmental protection at the same time, the financial matters. And these environmental laws and regulations are developed by federal agencies. I'm going to use the word federal. In the US, that really represents like in India, central government. So then state and local. So state and local is kind of the same terminology, but we use federal, and in India you use central government. So just remember that term federal means the central. And one thing, the federal government passes some regulations, so the state and local governments must abide those federal laws. If they want to propose additional laws and regulations, they could do that one, but they could be more stricter than federal laws. You cannot dilute the federal laws. So you have to follow the federal laws as the minimum laws, and then you can, the states and local governments can pass more stringent laws. So that is permissible. And one thing you need to remember that all environmental designs and practices must comply with these laws and regulations. So similar to building codes, let's say you are designing the foundation, designing some, building, you really have to follow the codes, right? You need to know which code you need to follow. You know that one right up front, and then you try to, design according to that, right? So same thing in environmental practice, these environmental laws and regulations work like, codes. So you must follow, these environmental laws and regulations in the design, the work that you do. Okay, so hence it's very critical to review these first. Always like that, right? If you're designing a foundation or anything like that, so you look at the building codes as the first thing, right? And what are the requirements? So you try to start off with those minimum requirements and do the analysis, and then change your design to meet your safety requirements. So this is the important thing that you need to remember. So if you are getting involved in the waste issues or landfill issues, first thing that you need to know is what are the environmental laws and regulations that you have to abide by. So there's we use laws and regulations. So what is the difference between law and regulation? So this is what you need to really be clear about it. So law or act means the same thing. It's passed by a government, a legislative body. So the elected body. In the US, it's a US Congress. In India, it's a parliament, right? So that parliament, let's say, passes a law or act, but these politicians, they don't know anything technical terms. So basically, they define the law in terms of the general terms on what needs to be accomplished, right? So what is the goal of that law? So they define that goal in general terms in the law or act, and then for the technical details, they assign one of their agencies. For example, in the US, let's say federal government, US Congress passes a law, then it assigns US EPA as authorized agency to develop the technical details on how to achieve those goals. So those technical details are called regulations. So in India, it could be Central Pollution Control Board, and they have regulations. They may call it with some other term. So the one thing that I want to mention is that I'm going to use. I'm going to explain more from US point of view, but I will also cite some references that you can refer to for Indian conditions. So these regulations, so I will appreciate if everybody mutes it. Somebody is talking. Yeah. So regulations become a legal requirement. So you know the difference between law. So the regulations are developed by US EPA. Those are technical details, but are obligated to follow those things. They are legal requirements. For example, Central Pollution Control Board, requirements under the government law, then you are required to follow that. So
Sir?
Sir, we lost the connection, sir.
Yeah, it's just coming. Yeah. Sir, could you please unmute yourself?
okay, sorry. Okay. All right, so I made it clear what is the difference between law and regulations. So the regulations, you are required to follow. So if you don't follow the regulations, means you're not following the law, and then you will be punishable under the law. And as I mentioned, you will have a federal laws and regulations. At the state, similarly, you could have a state laws and regulations, and even at a local level, you can have laws and regulations. So this is important to remember that. So in the U.S., over the years, this shows the number of regulations or laws that were passed. So as you see, from since 1960s onwards, so the number of environmental regulations have gone up so much. And all these environmental regulations are to ensure clean air, clean water, and clean land. And that's the reason, because of these regulations, I can take my glass and take the water under the running tap and then drink it. So that water is that clean as a result of these regulations. So and they do have a lot of difference it makes. So according to in the US, waste is classified into these types. Solid waste, we call it. Solid waste can be municipal solid waste or hazardous waste. And then you could also have a radioactive waste and infectious or medical waste. So we're not going to deal with this radioactive waste or this medical waste. Mainly, we are dealing with solid waste. This is the focus of this short course. So if you are dealing with the solid waste, the environmental laws, in the US that are applicable are Resource Conservation and Recovery Act, it's known as RCRA. And you can also, you need to apply Clean Water Act and the Clean Air Act. And then, this other law is applicable in some situations where you have an abandoned landfill or dump site. Then you have to use this circular landfill for that purpose. So these are, if you are in the US and if you want to design a landfill, and these are the laws that you should be aware of. Out of these laws, the main thing is this Resource Conservation and Recovery Act, or called RCRA Act. So this is the most important law that deals with the landfills. So under this RCRA is the act, right? And so it's a law that is passed by the US Congress. And under this law, US EPA developed regulations or technical details on how to dispose of solid waste. And this law, these regulations defined what is solid waste initially. What do we call solid waste? Not as a physical term. There's a deep meaning to it. And then it also defines what is municipal solid waste and what is the hazardous waste. So that's distinction also should be made clear, because it's a totally different game. If you think about municipal solid waste versus hazardous waste, how do you manage those wastes? Even how you dispose those wastes is a different thing. So these regulations, US EPA regulations, also give you the minimum requirements for municipal solid waste landfills and hazardous waste landfills. So if I'm in the US and if I'm dealing with municipal solid waste, if I want to design a municipal solid waste landfill, then first thing that I need to do is to look at these requirements, minimum requirements. As I told you, in our designs, in civil engineering, any design you do it, you check the code first, right? So same thing, this is like a code, I need to look at what are the minimum requirements for municipal solid waste. If I'm dealing with a, hazardous waste landfill, then I need to look at, what are the minimum requirements set by the government, because we need to follow these regulations. If you don't follow these regulations, you are violating the law, you will be punishable. So that's the important thing. And then, so RCRA landfill regulations are important. So if I'm dealing with municipal solid waste landfill, under RCRA, the so-called subtitle D regulations, there are sections 40 CFR 257, 258. I will mention these things. If you click these links, you take it to those documents, and they will spell out the minimum requirements for municipal solid waste landfill. Again, this is the first thing that one has to do if you really want to start designing a landfill. And for hazardous waste landfill, if I'm looking at that one, then you have to look at the RCRA subtitle C regulations. So 40 CFR 264 and 265. So these regulations are here. So the first thing that you have to do is get hands on these regulations. So you need to look at these are the minimum requirements that you have to meet. Okay, minimum requirements are not always, okay, right? I mean, like, the building codes, you say the minimum, thickness of the beam is this one, minimum reinforcement is this one. So you have those building codes minimum requirements, but you start off with those things and do the analysis and see if the performance, performance is satisfactory or safety, is satisfactory. And then you change the dimensions, basically you make towards the safety side, and then you design and come up with a final dimension. So CFR stands for Code of Federal Regulations. That's where all the regulations that developed by federal agency, federal regulations, not only environmental, but other regulations can be also available under this text. So I'm not an expert on Indian environmental laws and regulations, but in terms of the landfill regulations, I did basically the internet search. And I also, I'm aware of some of these things from the presentations by Indian researchers. So in India, you have Environmental Act of 1986. Under that, Ministry of Environment, Forest and Climate Change, they passed a law, rules. They are called Solid Waste Management Rules in 2016. So before 2016, there were other ones, Municipal Solid Waste Management and Handling Rules 2000, but those are replaced by these Solid Waste Management Rules. So right now, again, like just CFR in US, you have a gazette, in where India publishes all these regulations. So if I'm in India, first thing what I would do is I look at the solid waste management rules and see what are the requirements that are set forth in that one. So here is the link. I will, as I mentioned, I will post this presentation in the chat box right after my presentation. So you can click this link and then you can get a PDF document. And as I cannot overemphasize the need for looking at these things first. If you are working in industry or if you are a student, if you are a researcher, you need to know what are the rules that are set forth, right? So these rules are for solid waste, they call it. They don't even mention municipal solid waste. So in this solid waste management rules, so you have to be really careful about, how it is defined in the regulations. So there is a definition of what solid waste. You need to look at what it means, solid waste here. I'm not going to go over these, read out these things because I'm going to give you this presentation. You will have it, and even in the solid waste rules, solid waste management rules, you will find this one. And there it also defines a sanitary landfilling, and it explains about the facility designed with protective measures against pollution of the groundwater, surface water, fugitive air dust, all the things that we typically do, greenhouse gases, persistent organic pollutants, slope instability and erosion. So all the typical things that are required in the US are also kind of defined here also. And the dump sites, obviously you don't want to have a dump site, but if it is not a sanitary landfill, then it's a dump site. So if you go into these regulations, as I mentioned, I cannot overemphasize the need for you to read these regulations, okay? Rules, they call it rules. So in this one, Schedule 1 deals with the specifications for sanitary landfills. So in that one, you have these subsections, the criteria for site selection, criteria for development of facilities at the sanitary landfills, criteria for specification of landfilling operations and closure on completion of landfilling, criteria for pollution prevention, criteria for water quality monitoring, criteria for ambient air quality monitoring, criteria for plantation at landfill sites, criteria for post-care of landfill site, criteria for special provisions for hilly areas, closure and rehabilitation of the whole dumps. So these are all, specified in the Schedule 1 of solid waste management rules. So again, this is not a long document, and you can download this PDF and look at it. So what I did is sometimes, we don't have time to even download and read it. So what I did is for the benefit of all the attendees for this course, so I just cut and pasted those sections reproduce that one from the solid waste management rules. So here is the first section on criteria for site selection. I'm not going to go over this one, but I just wanted to at least have, if you have these on the slides, you would probably read them rather than downloading the PDF and look at it. This is not an abbreviated version. These are the complete details from the solid waste management rules. So and these are all the things that I mentioned. C, D, criteria for water quality monitoring, criteria for ambient air quality monitoring, criteria for plantation at landfill sites, criteria for post-care of, all the things that I mentioned, closure and rehab of old dumps. So you need to have an idea, right? What is the, the central government, came up with, what are the Central Pollution Control Board regulations are. So I want everyone to read this one. So anyone working on landfills in India, students, researchers, practitioners must know these rules, right? From working in this field for many years, I'm not sure about the scientific basis for some of the rules. So in my opinion, some rules seem to be questionable, but those kind of things, happen in every situation. So now I'm more familiar with the U.S. laws, so you can compare and contrast. So that's the best thing that you can do is, okay, you read about the Indian rules and regulations, and then compare with the U.S. regulations and see where the differences are. That would be a good exercise for students to do it. So this is the definition of the solid waste according to the US EPA in the US. Solid waste, you think in the physical sense, solid waste means solid, right? But that is not true according to this definition. So solid waste includes solids, liquids, semi-solids, even contained gaseous materials. So that's one thing I always have hard time, when I teach this course, when I explain solid waste definition, I always have a problem with these things. So, the solid waste doesn't mean that it's a physically solid thing. It could be liquid thing too, so, or semi-solid thing. So that's the, the definition that US EPA has, and then we, follow that in the US for our practice. And so, so don't take it literally. Solid waste means, really solid, okay? So no matter what, solid waste is a very generic term, and then it can be divided into two categories. So one is called municipal solid waste, and the municipal solid waste could be coming from households, commercial facilities, industrial, non-hazardous industrial, non-hazardous construction and demolition waste. So all that could be combined together, and you can call it a municipal solid waste. And if it is not a municipal solid waste, then it's a high hazardous waste. So you have only these two choices, either it's a municipal solid waste. Basically, we can simply say, municipal solid waste, non-hazardous waste versus hazardous waste. We don't call non-hazardous waste, we call municipal solid waste, okay? So you need to be very clear with this one because, it makes huge difference in terms of how do you manage this waste. So this is typical composition of municipal solid waste in the US, and, you can find these numbers changing depending upon the source you look at it. And you will have these kind of numbers for every other country that you can think of, okay? Just like giving you an example of this one. So now the question is, how do I know if the waste is hazardous waste or non-hazardous waste? Let's say I don't know where it came from, right? Or it came from all kinds of things, industries, and it's a kind of a mixed stuff. And how do I know it's hazardous waste or non-hazardous waste? So US EPA has given this definition of what hazardous waste is, okay? So what we do is we do this test and see if it meets the these requirements, then we call it hazardous waste. If not, we call it non-hazardous waste. So what are the things that you should look for, to characterize the waste, to determine if the waste is hazardous or not? One of these criteria, if it follows, then it's called hazardous waste. Look, well, first thing is ignitability. You need to look at it. If the waste is ignitable. Second one is corrosive. Is it corrosive or reactive or toxic? So if any of these characteristics are exhibited by your waste, then it's called solid waste. Not necessarily all of them have to be followed. Just, if it is ignitable and everything else is fine, then it's still called hazardous waste. So the point, I hope I made it clear, any one of the following characteristics, it could be, all of them, or at least if one of them is not satisfied, then it's, it's hazardous waste. So how do we test these characteristics? First one is the ignitability. So you look at this one. So there's a more explanation here. For example, flash points of less than 140 degree or 60 degrees centigrade, then it's ignitable. Corrosivity, you can see pH is less than or equal to 2 or greater than or equal to 12.5, then it's a corrosive. So it automatically becomes a hazardous waste. Okay. So if one of them is satisfied, you know that it's hazardous waste. But let's say these are okay. Then you look at reactivity. Again, I've given you the description about how you test for reactivity. So in a common sense, just if it reacts violently with water, then so there is a descriptive way of how you characterize the reactivity. And then the last one is the toxicity. How do you check the toxicity? You do the TCLP test, toxicity characteristic leaching procedure test. This is the procedure in the table. This goes in details. Everybody knows what TCLP test is in these days. And then what you do is, this is a leaching test. You do this, take the waste, whatever the waste that you're talking about, representative amount of waste that you take it, and then you do this leaching test, and then you need to analyze that leachate that comes out from that for these chemicals. So you see this one. These are combination of organics and inorganics. You see this one. So you in this table, these are all the different chemicals. So you have to specifically test for these chemicals, and these are the chemicals. So these are the only chemicals that you have to test for. And then you look at what the concentrations are, in your leachate. If the concentrations exceed, these regulatory levels, then it becomes hazardous waste. So not all of them, even one, for example, lead, right? If the lead concentration is more than 5 milligrams per liter in your leachate, then it becomes a hazardous waste. Let's say everything is fine, except leachate concentration is more than 5 milligrams per liter. So it becomes a hazardous waste. So then, you cannot use the municipal solid waste landfills. So you have to send these waste to hazardous waste landfills. So it's a totally a different game that, you have to play depending upon whether the waste is hazardous waste or non-hazardous waste. So the municipal solid waste, that's the waste, that's the non-hazardous waste that comes from residences, industries, institutions and other things. So, we have an engineered waste containment system. So MSW landfills, they have a liner system, leachate collection removal system, final cover system, gas management system, groundwater monitoring system. As per the regulations, you need those things. This is not about, my way of thinking that these are good for a landfill, to have it in a landfill. No, these are the minimum requirements that you have to have. And you have to design all these things based on sound engineering principles. So if the waste is characterized as the hazardous waste, then you have to do all these things that you do for municipal solid waste landfills. But you have to introduce a lot of redundant design. Instead of a single composite liner, you have to have a double composite liner in hazardous waste, because you don't want to take any chance of the contamination going into the subsurface. So basically, you follow the same design criteria as design methods as municipal solid waste landfills, but you introduce a lot of redundancy. So these landfills, in municipal solid waste landfills or hazardous waste landfills, they cannot, you cannot dispose of the liquid waste in them. MSW landfills, you cannot have a liquid waste. So if you have a liquid waste, only way that you can dispose them of is in surface impoundments. So MSW landfills, hazardous waste landfills will not accept any waste that has excessive moisture. So it's called, they do the paint filter test, and if it does not pass, then you cannot really dispose that one in a landfill. So if you have that liquid waste, then you have to put it in a surface impoundments, or there's a different terminology for this one: ponds, lagoons, different things. Just showing the schematic of what a municipal solid waste landfill looks like. Basically you have, this is, let's say you have a geological formation like this one, and then you have a liner system at the bottom. You excavate down depending upon how much capacity you need, and then you construct the liner system, and then you have a leachate collection system, and then you fill in the waste. That's called operating conditions. Once you fill it up, then you close it with the final cover, and then you always have to monitor the groundwater at the site, even before you start constructing the landfill, to establish the baseline groundwater conditions. So you will have a set of monitoring wells on the downgrading side, one set of the wells on upgrading side. So you can see if there is any leakage from the landfill, you will be able to detect them. And then you also have to have a gas collection and removal systems in these things. Okay, so those are the typical things. So in just like solid waste rules of India, in subtitle D regulations, MSW, RECRA, as I mentioned, so they also have these specifications on what the minimum requirements are for municipal solid waste landfills. So I'm not going to focus on hazardous waste landfills and impoundments. Basically, if you know how to design a municipal solid waste landfill, you could apply the same engineering principles to design hazardous waste landfills and impoundments. So a lot of times in my teaching of the courses, I spend a lot of time on municipal solid waste landfill, and then I will tell at the end, how you change things for hazardous waste landfills and impoundments. So these are the requirements that you see, in the specifications. As I mentioned, this would be our starting point. This is my building code, right? Or code that I need to follow for design and landfill. So these are the things that are as per the US EPA. But you have the same kind of things in solid waste rules of 2016 in India. So the location restrictions, where can you have a landfill? It's called locating landfill or siting a landfill. So you have to follow these requirements. For example, in the US, you cannot have any landfill 5,000 feet from the airport, or 10,000 feet from the airport, depending upon the flights that come in. And landfills should not be located in floodplains. Landfills must not be located in wetlands. So it will give you all these things. Must not be located 200 feet of fault area. Landfills cannot be located in seismic impact zones, right? Because you have a seismic conditions. Landfills must not be located in unstable site subway conditions. So you have all these requirements on where to put a landfill. So you have to meet these requirements. For example, seismic impact zones, every country has this seismic city maps. In the US, this is the map of US. So this shows, the seismic impact zones. So if you have a landfill, in non-seismic zones, then you don't have to worry about it. If you have a landfill in this these shaded areas are seismic impact zones. So if you have a landfill in those locations, then you have to do the stability analysis for seismic conditions. It's not like, okay, if you have in a situation like this one, you have to, the regulations tell you what extra analysis that you have to do. And those are the federal regulations. Federal regulations in India is like a central government regulation. So then states could have different regulations. I live in a state called Illinois. So Illinois has a different regulations. So these regulations, I don't have to go in detail, but these are more stricter than the federal regulations, or these are even additional requirements than the federal requirements. So the federal requirements are compulsory, and you can have more stricter or additional requirements at the state level or even the local level. For example, okay, I'm going to have a landfill in Hyderabad, so whatever the Hyderabad Municipal Corporation, if they want to come up with some additional requirements, then those have to be also followed. So that's about location requirements. Operating criteria, and so you cannot accept hazardous waste, even by chance. So there should be certain testing protocols to make sure that, first of all, you need to look at the source. If you have unknown source, then you have to, analyze if the waste is hazardous or non-hazardous. Only non-hazardous waste is, taken in a municipal solid waste landfill. So if it's a hazardous waste, then you send it to hazardous waste landfill. So, hazardous waste landfill, because it is built with a lot of safety precautions, so it costs a lot of money. So they have a tipping fee, right? In the US, every time you take the waste to a landfill, they charge you by weight. So, hazardous waste costs a lot of money to dispose compared to municipal solid waste. And then, these are the regulations. These are the things that everybody has to follow. So they have to have, provide a daily cover, okay? So you place the waste and you are done for the day, and you cannot just walk away. So you need to put a daily cover. It could be a layer of soil, layer of mulch, or layer of tarp, or something that needs to be placed. So this is not an option. So a landfill operator cannot really walk away. So he has to have this one. A control on-site disease vector. So if you go to a landfill, you will see a lot of birds and all kinds of things like that. So they have to control that one. They need to do routine methane monitoring, eliminate most open burning, control public access. You cannot go to a landfill, just walk into the landfill, at any place. So, and construct run-on and run-off controls, because when it rains, you have to see where the water is going, and surrounding water where it is going. So, and control discharges to surface water. So you don't want surface water to be contaminated, and you cannot take a liquid waste. So you need to keep records that demonstrate the complaints. So these are all the requirements put on the operator, and the operator has to conform to these operating requirements. So that's, again, it's not an option, it is by regulations. If the operator not following any of those operating criteria, he or the company will be shut down, or they will be responsible for all the damages, and sometimes they go to jail also. So design criteria. So most important design criteria is the liner system. So I know a lot of people do research on liners, okay? And the first thing that I will tell them is, look at what is the requirement for the liners, okay? Just don't randomly do research on liners without knowing what is the minimum required, right? So in the US, and many countries, they adopted the similar thing. So basically here, we need 2 feet of compacted soil with less than 10 to the power -7 centimeter per second. So we use the feet system. So, you can convert this maybe 0.6 meters. And then on the top of it, you need to have a geomembrane, a flexible membrane, if it's a HDPE, 60 mil minimum. And then you need to have a leachate collection system on the top of it. Basically, you have a drainage layer or the pipes. It doesn't really say anything about this one. So whatever in the regulations is this, okay? You need to have a flexible membrane liner. You need to have a compacted clay liner. You need to have a leachate collection and removal system. It doesn't say what it should be, yeah, but it should ensure that leachate does not accumulate more than 1 foot, 30 centimeters above the liner at any time during the entire life of the landfill. So you can basically, typically we will have a drainage layer, we will have a set of pipes, and we will have a system to collect and then remove the leachate, so that we have a 30 centimeters or less leachate head, throughout the entire landfill. So this is what you need to look at it. Okay, if I'm doing the research on it, okay, what can I do better than this, right? So this is the thing that this is called. It gives you 2 choices. This is what the prescriptive choice, right? And then you cannot really say, oh, I'm going to put 2 feet of this and the geomembrane. And then, so you need to come up with the details. You need to do the analysis of contaminant transport, see if this 2 feet is enough, right? So the analysis goes. So this is the starting point. So instead of 2 feet, your analysis may show I need 3 feet. So like how we do the design of steel structures or concrete structures, whatever it is. So this is the minimum requirements, and then you follow that one. So only problem in liners is that you cannot do anything with the permeability, right? Whereas if the slopes, if the shear strength is not enough, you can do something. You can flatten the slopes, do something for that one. But permeability is a requirement that you cannot do much. So you have to make sure that your material has the permeability of that. So they give you a second choice. So I like these regulations. Okay, regulations give you the prescriptive solution, kind of what is the standard solution that you start with, but also they give you the option. Okay, this is the second choice. In the second choice, they don't say anything. Okay, I don't want to say anything about these are regulations, right? The regulations don't want to say anything about the liner system. You come up with whatever you want, right, as a cover. But only criteria that I have is that I'm talking from the regulation point of view, regulatory agency that is, seeing your design. They say that, okay, this is my compliance boundary. Generally, is the waste boundary or 100 feet or 500 feet from the waste boundary. That's my compliance boundary. So if I draw a line, go down to the uppermost aquifer, and then look at this point. So that's my complaints point. So, I need to demonstrate that at this complaints point, my contaminant, for example, if it leaches and it leaches goes down, and then, in the groundwater, it might flow horizontally. When it comes to this complaints location, concentrations do not exceed these standard levels. So, these regulations tell you these are the contaminants and these are the concentrations. So you come up with whatever you want. So I love this, option, right? I mean, you can go with the other option or with this option, whatever you wanted, but you have too much burden on you to demonstrate that during the entire life of this landfill, you will not exceed the concentrations at this complaints point more than what are shown in this table. So that's challenging. You need to do the contaminant transport modeling. And when you do the contaminant transport modeling, there are a lot of assumptions on the input parameters, and it's very hard to justify. So even though they are there in the regulations, but most of the times we go back to the prescriptive one and then change the design to meet the performance requirements. So then groundwater monitoring corrective action. So uppermost aquifer is the most important one. You want to monitor all the time. So you need to have a set of monitoring wells, and you need to have a sampling and analysis program. And they tell you what kind of chemicals that you need to analyze. It's called detection monitoring. And then if you find some chemicals exceeding certain levels, then you go into assessment monitoring. In the assessment monitoring, then you need to add more chemicals and monitor those things. And then, do the statistical analysis. And if you see that, these chemical concentrations are exceeding in the groundwater, definitely that's due to the leakage from the landfill. Then you need to have a corrective action. Corrective action is a remediation of the groundwater. So you really need to do something. In landfill cases, once you fill in the waste, you cannot do anything to the liner. So, a lot of times you have to put a slurry walls or other things. So that's why you need to be extremely careful in design of the landfill liners, because there is no second chance to fix it. Because once you put a lot of waste, how can you go back and replace change the line? So for the cover, once you fill it up to the capacity, so this is the minimum requirements for the cover. So basically 2 layers, 18-inch and 6-inch. It shows you the permeability requirement. The one thing that a lot of people don't realize, the permeability requirement, you should read this one, is must be less than or equal to bottom liner system or the natural soil that you have, but not greater than 10 to the power minus 5. So it should not be greater than 10 to the power minus 5. That's one thing. But if you have a landfill, a old landfill, let's say abandoned landfill that does not have a liner system or a flexible geomembrane liner, so what is the permeability of the bottom soil? So that permeability of this one should be less than that soil that existing naturally. Or if you have a modern landfill with a geomembrane in the bottom liner, then you need to have a geomembrane in this cover system in order to meet this requirement. So basically what they are saying is this barrier layer has to have a permeability less than the barrier layer that you have at the bottom of the liner. So that's again important point that everybody has to remember. So for engineered landfills, you need to have a geomembrane in the top cover. But if you have a old landfill that does not have a bottom liner, geomembrane, there's no need to put a geomembrane in the cover. I don't understand why you need to put it in. I mean, I know it reduces the infiltration, but you can actually control the infiltration through proper soil and the proper drainage material here. You don't need a geomembrane in the final cover. Just even in the US, for old landfills, I worked on some old landfills where we didn't have to use the geomembrane in the final cover, and we used barrier layer and drainage layer and vegetative cover layer, and we closed the landfills. So then you need to have a closure plan. This is right in the beginning of the landfill, even before you constructed it. You need to have a final cover design. All the things. These are all everything should be decided upfront. So per the regulations, once you fill up the waste, so within 30 days of the final placement of the layer, you need to start putting the closure cover. The post closure is another important thing. Once you put the final cover, the landfill operator cannot walk away. He has the obligation, the landfill operator has the obligation to monitor the landfill for 30 years. And then you need to continuously document how the landfill is performing, right? So, make sure that, it's performing the way it's supposed to be. So you need to make sure that final cover is is maintained properly and it's performing fine. And you need to think about, how leachate is collection is happening, and then how groundwater monitoring is happening, how the gas monitoring is happening. So you need to really document all these things, and then you need to submit regularly to the regulating agency so that they know that things are working fine. Now, post-closure is, you're talking about 30 years, right? 30 years after, putting the final cover. What happens that landfill operator will disappear, right? Announces bankruptcy or leaves the country, whatever. But, because of that uncertainty, the landfill operator has to deposit the money during the landfill operations. So that's called financial assurance criteria. So if you have a state government or federal government, if they own a landfill in US, that could happen. So then, these governments are going to be there forever. So that's not a problem. But if you have a private entity, then you really need to, have them required. This law requires you to put in money in an account that the regulating agency would have access to in case if they are not able to maintain the landfill. So those are the kind of municipal solid waste requirements, landfill requirements. Hazardous waste landfill regulations are there. So if you are dealing with hazardous waste landfill, so there are other set of landfill requirements. So this builds on there were additional requirements, and these are clearly spelled out in the regulations. So you go into this 40 CFR 264, it talks about all these different things. If I'm dealing with landfills, incinerators, or surface impoundments, you go in there and look at what are the requirements, specific requirements. Again, those are the starting points, minimum requirements. You have to fulfill those things and then build on the top of that whatever is needed based on the engineering analysis and performance. And then, as I mentioned, that RECRA is the main law that governs the landfills design in US. But you need to also look at the Clean Water Act. Clean water controls all the discharges of waters, okay? But in case of landfill, you have a storm water, right? You have a leachate. So those things, if you want to discharge into nearby surface water, then Clean Water Act kicks in. So you cannot do certain things according to this. Clean Air Act kicks in because you have gas emissions, right? Methane and other things that are coming up. And as per this law, you cannot emit these gases into the atmosphere. So the Clean Air Act kicks in, because of that. And then if it is an old landfill, then, and it's posing a lot of problems, then this Comprehensive Environmental Response Compensation Liability Act kicks in because, hey, it's posing a problem to the public and the environment, at an unacceptable way. So, hey, we need to do something about it. So, then you have to really act on it. And those projects are taken under this law. And as I said, the states have different requirements. They are more stringent than federal regulations. So if I'm working in a state, I need to know the federal regulations and I need to know the state regulations. I need to know the local regulations, what city requirements that I have. So for example, you need state regulations. Illinois state has these regulations, California has these regulations, New York has these regulations. So you have to do the same thing. So which state you are in, which city you are in, and then you follow those requirements. I mean, these vary quite a bit, so that's why you cannot talk about this in general, because there are setback distances. Generally, the local requirements say that you cannot have a landfill, in these particular areas, or the zoning requirements, other things. So they have more, restrictions on the landfill. So I think I'm, running out of time, and I just want to close. So hopefully I didn't go too fast. And as I mentioned, after my presentation, I'm going to put this presentation in the chat box. Please download it and then go over it again. And if you have any questions, you can just contact me. So in closing, what I want to mention is laws and regulations are there to protect public and the environment. So all the government agencies, the environmental agencies, their goal is to protect the public and the environment. So they have nothing to gain by asking you to do more, because they want the public to be protected. And these regulations are the minimum requirements that must be conformed. So you have to follow these minimum requirements. That's what bothers me a lot, because a lot of people work in this waste issues and landfill issues. They don't know what the minimum requirements are, and they start doing something with no relevance to how it should be done in practice. However, these minimum requirements are there, but they are flexible for performance-based alternatives. So you can, go with that one. Even minimum requirements is not enough. You need to do the engineering analysis and perfect the final design. And also, if you find an alternative design, in US, we can talk to the regulating agencies and they, can get a waiver to go with the performance-based alternatives. And anyone dealing with any aspects of waste and landfills must be fully aware of the prevailing or applicable laws and regulations. So especially researchers, you could do some research, but if it is not allowed, what is the use of doing that research? And one request I have for all the attendees, I don't know how many of you have actually visited a landfill, okay? So I suggest you to visit a landfill. Hopefully, if you have an engineered landfill, municipal solid waste landfill or hazardous waste landfill, so go and visit that one. So you can see how, various components are engineered. Or, if you don't have a landfill, you look at the waste dump and realize the importance of engineered landfill, with all the problems that you see it, okay? So it's amazing. If you want to just sit in the lab, think about what research could be useful for landfills, you are wasting your time. So you just really, it's amazing experience, awareness that you get by going to a landfill. So I want to again reemphasize, if you are starting or if you are teaching, I would recommend you to get hold of this book and see this section. So these are all the different ways that you design different components in a logical sequence. And at every, for these chapters, in the beginning of every chapter, I have specific regulations mentioned. So you start off that one. What is the minimum regulations that I need to follow? And then you build on the analysis and then perfect that design. So I would highly recommend you to go through these things, if you're embarking on anything to deal with waste and landfills. So here is my contact information. You are more than welcome to contact me by email or other ways. I will be happy to help you out. And with that one, I want to thank you all.
Thank you, sir. So thank you so much for enlightening us. So from the participants, may I take one or two couple of quick questions?
Yeah, Dr. Hanumanto, can I ask a question? Quick question?
Yes, please.
Hello, good morning, Professor Reddy. I understand that it's midnight and you have taken wonderful lecture. I'm Deepak Swami and I've attended earlier talks also, which you organize regularly. So my question here is about the distribution of permeability in the constructed landfill on site. So whenever we construct the landfill on site, there are variations in the hydraulic conductivities. So what are the laws which governs to maintain these hydraulic conductivity, and is there any law specifically related to the stochastic distribution and its limit on the hydraulic conductivity of the landfill liners? Thank you very much.
So in terms of the hydraulic conductivity testing, always the lab values are lower than typical field, what you expect in the field. So in this landfill design and construction, so one of the requirements is that during the construction, you have to do the field testing. So there are different types of, the field tests that you can do, basically, during the construction of the especially the final covers and the clay liners, compacted soil liners. So, the infiltration test, there's a Boutwell permeability test. So, after placing certain amounts of, after constructing the liner, after every certain volume, you have to do the testing. So there are requirements on how much testing that you need to do. I don't think they really do a lot of statistical analysis at that time. So you need to really still, look at meeting the requirements of 10 to the power of -7 centimeter per second at every location that you test. So that's kind of the minimum that you have to follow. So again, hopefully I made it clear. It's a very simple. You design your liner based on your lab testing, realizing the fact that it could be higher in the field due to micro cracks or the fractures and other things. So and in the field, even during the design phase itself, you go to the field and construct the liner based on the specifications that you're proposing, and then do the field testing, and then make sure that you get 10 to the power of -7 centimeter per second at all the locations that you test.
Okay. And just last thing to add up into this question is, what are the chances that we will deviate or the construction may deviate from these values?
No, they have, during the construction, if something is not right, then you can fix it right then. So
Okay.
either, adjusting the moisture or adjusting the compaction, just, you need to, you have developed a compaction criteria, that results in the permeability design, required strength and all those things. So you basically, there's, based on my experience, if something is not satisfying, then you need to fix it. You need to really, so you make sure that as constructed landfill liner meets the specifications. So once you constructed it, once you place the waste and everything else, then you don't have any control on what you would do. So if anything is, if it's not functioning, then that will show up in groundwater monitoring system.
Yeah. Thank you very much, Professor Krishna Reddy. Thank you very much.
Thank you.
So Krishna, good morning.
Good morning, sir. I know it's like a 110. Professor Rao is making me work.
It seems that Professor Rao is the connecting cord between both of us. He brings us to IIT Bhubaneshwar either virtually or physically.
Physically, yeah, I know. And last time we met.
Last time also we went to IIT Bhubaneshwar together, if you remember.
Yeah. I remember a nice walk, morning walk we had together. That was beautiful. Yeah.
Well, good to see you.
Yeah,
I know you are doing extremely interesting things, very intricate things. Keep it up.
Yeah, I will be happy. I mean, like my goal, at this stage of my career is to, educate as many people as I can.
Career has started just now for you.
Yeah, I know. So that's why I'm able to give the lecture at 1:10 a.m.
One reaches the lecturing stage when he realizes that he couldn't do much, and then he has to improve others.
That's
Okay,
nice.
meeting
But
you.
it's nice. Yeah. All right. Thank you so much. Yeah.
So thank you so much, sir. And
Sure.
we are extremely sorry for the little inconvenience.
No problem. I'm not doing it every day. So I will again, attendees, if you are going to be there tomorrow, and if you have any questions on today's lecture, I will be happy to answer tomorrow too. So I will post the PPT. So then, while Professor D.N. Singh is, talking, then I can do that one. So just thanks again, Dr. Rao.
Sir, thank you so much.
Yeah, thank you.
Hello.
Yeah, hello.
Yes.
So Krishna Reddy sir.
Yes.
Thank you very much, sir. It was really wonderful to hear you after a long time. And I'm Lakshmikant from Bangalore.
Yeah, nice to see you. Are you in charge of the landfills there in Karnataka or no?
Exactly, sir. I'm working for solid waste management in Karnataka.
So very good. So you might have yeah.
Thanks for your interest. You have taken so much of interest in sharing all the information.
No problem. It's my pleasure.
So thank you, sir.
Thank you. Thanks, Dr. Rao.
Yeah, thank you, sir.
Bye.